Hi class, this video is going to help with 4.3, which is more of the kind of the same things we've been talking about. Complements, right? Like if there's 25% chance of one thing, then there's 75 of the other. That complement, they add to 1. And the conditional probabilities and Bayes' theorem, we've sort of looked at conditionals a little, but this is like way more in detail. And then Bayes' theorem, we'll touch the idea of it, but we won't, we probably won't use it as much, but I want you to be aware of that theorem. So let's start out with, what if I say the probability of at least 1? So anytime I'm saying that to you, if I let A, whatever that event is the probability of getting at least 1, then the probability of not A would be getting none of that event. So when I'm asked at least 1, I have to use the idea of none in order to be able to figure out that problem. So at least 1, I would find none, and then it would be a complement. So what do I mean by that? Let's look at this first question here. A study of Square Trade found that 6% of damaged iPads were damaged by bags or backpacks. If 20 damaged iPads are randomly selected, find the probability of getting at least 1 that was damaged in a backpack. And then we'll start there, and then we'll answer the other question. Okay, let's go right here, and we're going to see, find the probability of getting at least 1 damaged by a backpack. So we have 20 backpacks that are damaged. So how are we going to start with this? Let's think of the probability of a damaged backpack, I'll just say bag because I'm lazy, is 0.06. So the probability of a damaged bag is 6%. So then what's the probability of a not damaged by a bag? It's still damaged, but what's the probability that, you know, you sat on it or it fell or, you know, whatever other way? That's going to be 0.94, right? Because those are complements. It's either damaged by a bag or it's damaged another way. So we have to use this idea here to figure out for each of our 20 bags. So think about it this way. So if I want the probability of not A, that's going to be not damaged by a backpack from our original. So you could have wrote that, but the not from our original question. We would look at that first damaged one. The probability of it being from not a backpack is 0.94. So we would have 0.94 for the first one, and then we'd have to times it by 0.94 for the second, and the second, and the next, and the next, and the next. So this would keep going until you've gotten to that 20th one, right? So we would say this is 0.94 to the 20th power. However many I had, the probability for each one is 0.94. So this is an and, this one, this one, this one. Again, I've said it before. You're probably multiplying almost every time with a probability that keeps going. So you multiply a lot more than you ever add. That's where I'm going with that word. So think multiplication. This will give me the probability of not the event I'm looking for. So I'm going to get out my calculator and I'm going to do 0.94 to the 20th because I don't want to times it by itself that many times. And I got 0.29. We'll just go 2 decimal places. It's 290, so it's perfect. So then what is the probability of getting at least 1 from our event? So the probability of at least 1 is damaged by a backpack. Okay, then I would take that 1 and I would subtract off that 0.29, and that would give me 1 minus 0.29 is going to give me 0.71. So the probability of getting at least 1 bag that was damaged by a backpack is 71%. Okay. All right. So if I'm asked at least, we just have to know that we're going to have to use complements. So what else does this ask? It says, is the probability high enough so that we can reasonably be sure that at least 1 is damaged? 71? Yeah, I would say that's pretty, I mean, that's pretty high. I would say it's high enough. to say it's damaged by a bag. Okay, so that is our first idea for this section, at least one, using a complement. The next idea is a conditional probability, and that's like, what's the probability of it raining today given it rained yesterday? So that idea of given, and it's denoted with the line in between. So for this one, they gave B given A, and they're saying the way that you do the probability is you do the probability of and, those two together, and where are they both, divided by the probability of the second one. Okay, we could rewrite this as the probability of A given B is equal to the probability of B and A divided by probability of B. It doesn't matter how you write your letters, and you may see it both ways here and there, but these two are not necessarily the same answer. As a matter of fact, it's super rare that they would be, so I would just assume they're different. So, because you're switching things around. The and might be the same, but the dividing is not the same. So then you're getting a different answer. So let's do it. I have 4 examples of using this idea. So I'm going to do it from a chart because I think that's quite a few of your homework problems, and then we could do 4 questions from that same. So this one is another one of the drug things, which what I should say is if you test positive for COVID, if you really have COVID, right, that'd be careful. But I don't really know the data. So this one is you have a positive result or a negative result, and you actually use that drug, whatever it is, or you do not use that drug. So let's look at part A. What's the probability of a positive test result given the subject uses drugs? So positive test result given you use drugs. So we have to start with the and. Where are they both happening? So positive test results and they use drugs, 45. And if we add all these up, there's 555 total. So that we always have to know that denominator, right? So we're going to start with 45 out of 555. That's our and we're going to divide that by, maybe I should have wrote smaller so I could do the division. So 45 divided by 555 divided by, and then on the denominator, which one goes in the denominator? The probability of the subject uses drugs, that second one. So subject uses drugs, there's 45 plus 5 more would give me 50 out of 555. So there's our 2 probabilities. What you'll notice is if I write down that first one and I divide it by the second, I will flip it and the sample space disappears. So it's really just 45 out of 50, which is going to give me, I think it was 0.9. So 45 divided by 50 is 0.9. So think of that as 90%. So what's the probability of a positive test result given the subject uses results or uses drugs? You have a 90% chance. Okay. So what is the probability that they use drugs given they have a positive test result? So what is the probability that you use drugs if you have a positive test result? You would think 100%, but it's not. And I don't even know how accurate most tests are. I should ask my husband. Okay, so for this one, we got to find the and again. So uses drugs is 50. And, and a positive test result is only 5. Right? No, positive test results uses drugs, 45. Oosh-a-boosh. Couldn't think of the 45. I was looking at, well, my problem is I'm looking at my notes and I'm looking at the next question. So 45 is positive and you use drugs right here. I don't have to write the 555 if I don't want to. So then what is the positive test result one is both of these. So 45 and 25 is going to give me 70. So 45 divided by 70 is going to give me 0.64. So 64% use drugs given they have a positive test result. Use drugs given they have a positive test result. I always just think of this one, given. That line, just think of the word given. So here's our next one. What's the probability that you use drugs given you have a negative test result? So basically, if it's like marijuana and it's your job, did you get away with it? Okay, so what is the probability of uses drugs and negative? So uses drugs and negative was 5. See, that's where I kept wanting to write 5 in the last one because I was looking at my notes and I confused myself. And then the probability of the negative goes on the bottom. So negative you'd add, that's going to be huge. It's going to be 485. So 5 divided by 485 is 0.01. Okay, that's the decimal. If I move it over, it's like 0.000301. 3 zeros with a 1 for percent. So it's really, really, really small. And that's the probability you use drugs given you have a negative result. Not very likely. So you're more likely to get a false positive than a false negative. So next one, according to this, of course, this is totally made up, so who knows. But the last one, negative test result. So pause and try this one, and subject uses drugs, just to make sure you can do this one correct. So you can pause the video and try it, and then turn you back on. Okay. So this one would be negative, and the subject uses drugs. So uses drugs and negative are 5. And subject uses drugs is 50. So this is 0.1. So a little bit bigger. Notice these are opposite of each other. They're different answers. You're dividing by a totally different number. The tops might be the same, but you're dividing by a totally different number. And same with the top two. They're opposite of each other, which I did on purpose. Totally different answers, completely different question. So what does the book call that these are different? Is it's confusion of the universe? I don't know where they got that from. I almost skipped it, but they like write confusion of the universe in the all of their notes. It's in the book and it's in your homework. So it's just where the idea that they aren't always equal. There could be cases where they are equal, but they're not equal. So you have to actually calculate them out. You can't just assume they're going to equal if we flip A and B. Okay, Bayes' theorem is right here, and it's actually, we use this one to go from one condition to the next on occasion. Like this is, we won't use this very much because we usually just use our condition probability. You can use that for almost everything, but let's look at this one. So Bayes' theorem is saying A given B, you can do the opposite, B given A, times the probability of A divided by B, and get your answer that way. So it's a little different way to get the same answer. I do want to note that the word and a union symbol are the same thing, just in case you look up stuff and you wonder where that came from. So let's look at an example using Bayes' theorem, and then we'll just get to answer a couple more questions randomly from this homework. So a couple has 3 children. Find the following using Bayes' theorem. So I wrote out Bayes' theorem for you. I probably shouldn't have, but that's okay. So what's the probability of you getting 2 girls given they have at least 1 girl? So what's the probability of getting 2 girls given you have at least 1 girl? So if I did Bayes' theorem, it would be the probability of 1 girl given 2 girls, so switch, times the probability of 2 girls divided by the probability of 1 girl. So, I mean, really, we're going to use this if we probably already know the probability of 1 girl given 2 girls. So that's all right. But let's look at the probability for each of these. So one way to think of this is if I have a baby, it's going to be a girl. I'm going to use it lowercase because it looks like a girl or a boy, right? And then the next one would either be a boy or a boy or a girl, like either way. So there are 4 possibilities if you've had 2 children. And if I add, so what's the problem? Well, and then if I add another child, so do they have 3 children, 2 girls given? No, they only have 2 children. Probably getting 2 girls given you have at least 1 girl. Yeah, you only have 2 children. So there's only 4 ways to get that. You're either going to have a girl, boy, boy, girl, girl, or boy, girl. So I could write those out as I have a girl, I have a boy, girl, or girl, boy. I was trying to go in girl, boy, girl. Okay, boy, boy, girl. Either way. So either way that you want to think of that sample space. I apologize. All right, so then from here, what are we going to find? Well, what's the probability of getting 2 girls? Well, there's only one way to get 2 girls out of 4. What is the probability of getting 1 girl? Well, there is 1 girl here, 1 girl here, 1 girl here. So there's actually 3/4 of a way to get 1 girl from the 2 first. And then what is the probability of getting 1 girl given you have 2 girls? Think about that one for a minute. What is the probability of getting 1 girl given you have 2 girls? That's always going to be true. It's 1. What if we use, oh, it's all right. We'll just think of it as 1. It's just going to be 1 because you already have 2 girls. What's the probability of at least 1 if you already have 2? 100%. You have a girl. So that one was a little tricky. So let's put this together and we're going to see what this would equal. This would be 1 times 1/4 over 3/4. If we calculate that out, it's 1/3. Tricky, a little bit tricky on that one, a little bit tricky. Okay, so Bayes' theorem is handy if I'm going between the 2, but it's not as handy as just the regular formula, I think. Okay, so let's look at a couple more examples. I have 5 girls. What is the probability that my 6th child is a boy? I loved this one. I have 5 girls. What's the probability our 6th child is a boy? Everyone thinks your chances of getting another girl is like 100%. But every birth, what is your chance of having a boy versus a girl? 50-50. This is 50%. Still have half chance. Doesn't matter that I have 5 girls. I still have an equal chance that this next baby will be a boy or a girl. And now my friend that has 9 babies and 8 of them are boys probably doesn't think this is true. She's like, it's 100% chance it's going to be another boy. But funny enough. Okay, find the probability that at least one number in your 7-digit phone number is a 0. So at least, I'm bringing in that, so I'm going to have to use a complement. So let's find the probability of none of them being a 0. I had to think about that. Probability of no 0. Okay, that's our complement of our event. So a probability of none of them being a 0. So think about this. How many, so we have 7 digits. How many numbers can you put in for each digit? We can use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 digits. If I take off the 0 to get no 0, I would have 9 digits. So 9 digits for all 7 numbers would be 7 of those. 4, 5, 6, 7. So I would have 7 nines because I have 9 possibilities for the first one and 9 possibilities for the next, and so forth. What would be the denominator would be the 10 because that is your total. 1, 2, 3, 4, 5, 6. Oops, one more. So if I calculate this out, phew, big numbers, that's okay, 0.4783. So you're just gonna put it, it will give you like your answer. I'll just do it, I'll show you what it looks like a little bit, because you're gonna have 9, 1 to the 7th power, so 9 to the 7th is a big number, and then divide that by 10 to the 7th. It doesn't put it in exponent form, I guess, and you get 0.4783. Okay, so that's our probability of no zeros. So what would be the probability of at least one? 1, 0. I'm going to use the word 0 just because otherwise it's going to look like a 10. 1, 0 would just be 1 minus 0.4783, which is going to give me 0.5217. So the probability of having at least 1 0 is 52% out of a 7-digit phone number. We're going to do more of the timesing idea like this in the next section. So that'll come up more. It's funny because we did a little bit of the conditional in the last one, and then we focus on it. And then we introduce some, there's like a couple questions that kind of make you think about multiplying like this, and then the next section has more of them. All right, so let's look at this last one here. To reduce costs, laboratory costs, water samples from 4 public swimming pools are combined for 1 test for the presence of bacteria. Further testing is done only if the combined sample tests positive. Based on past results, there is a 0.006 probability of finding bacteria in a public swimming pool. This is a little tricky. Why I'm doing this one is because it's referring to one public pool. So the probability of 1 is 0.006. And then we're going to mix them and see what happens. So find the probability that a combined sample from 4 public swimming areas will reveal the presence of bacteria. And then we'll answer the other questions. So just find the probability. So if we look, we know the probability for each pool, the probability of it being negative is going to equal, and this is each pool. This is just the one pool, right? Because the probability for one pool testing positive is this. So the probability of it being negative is 1 minus 0.006. That's going to give me 0.994. So the probability of being negative is 0.994. And what's the probability of all 4 pools, because we did 4 samples, being negative? If you want the word pool in there, if you want to write it all the way out, you can. So the probability that all 4 will be is the 0.994 for the first one times 0.994 for the second one, plus 0.994 for the third, and then 0.994 for the last one. So you can put it in your calculators, 0.994 to the 4th power, and that's going to give me 97. So 0.9762-ish. So 97% chance that you will have a negative pool result. So what is the probability of a positive in the 4? It's just going to be 1 minus 0.9762, which is going to give me 0.024. So there's about a 2.4% chance that you will have a positive test result. Pretty low, 2%. And then what happens, so it's basically saying, is the probability low enough so further testing of individual samples is rare enough? I would say it's pretty rare that you're going to get a positive result, but If you do, you have to do more testing. So the way that they worded it in the problem in the homework says low probability, but further testing on each pool might be necessary. I don't want to swim with bacteria. I remember in Idaho when I lived there, there was like some kind of stomach thing that I can't remember. It was like really bad. It hit our pools, and they had to close down some of the pools, and people were barfing for like a month. It was like awful. I don't remember what the bacteria was. Okay, so for this homework, that's all the examples I have. You have conditional probabilities and definitely that idea of at least one coming up over and over. So you have to use the none and then subtract it from one. All right, good luck with your homework.